Welcome to a lesson with Dr. Powell. Let's take a look at how we can think of a matrix as a scalar. First of all, if we have a matrix here, think about, and we label it as X, think about how that would act as a scalar. Well, you basically just multiply it to each component. So we have a vector that looks like X, 3X. But equivalently, we can also think about X as a matrix and multiply 1, 3 right here on the right, and we would end up getting, let's see, 1 times 1 and 2 times 3, that'd be 7 and 13. Okay, we get 7, 13. So that means that 7, 13 is equal to X, 3X. So these two things are equal. Now, let's take a look at another way of thinking about this. This also means, so if these two things are always the same, that also means that this x diagonal minus this matrix should be 0. So in particular, x minus should be even like the 0 matrix. So x minus 1, and we have x minus 4, minus 2, minus 1, where I just take the two matrices and subtract them. So if this is equal to the 0 matrix even, because it behaves like multiplication by a scalar 0 even, you could think, that means that this column is the 0 column, and this column is the 0 column. So that's a 0 vector. Sure doesn't look like a 0 vector. How is it a 0 vector? Well, let's just think for a minute. This is a lot like taking in the first. This is a lot like saying x times 1, 0 plus -1, -1. See why that is? You can try it out. So the x goes on the top, not on the bottom, and then you add it across. It should be the same. Now think about how the matrix acts on 1, 0. It's like plugging in 1, 0 as a column vector multiplied to this matrix on the right. So think about that. That's like picking out the first column. That's like a 1, 1 even. If you matrix multiply, you can try that out. It's going to be 1, 1. Multiplying by this picks out the first column plus 0 times the second column. So you get this. And notice that for sure, that is 0, 0. Kind of fun. We can think of this column vector as actually being a 0 vector. Funny things happen when you let x be both a scalar and a matrix at the same time. Then your vector representations can get kind of funny. And it's precisely for this reason that if you take the determinant of this particular matrix, you're going to get a polynomial, and that polynomial would be the 0 polynomial. Why? Well, look, try to take the determinant of the 0 matrix. You're going to get 0. So the two should be the same if you're thinking of x as being both a scalar and a matrix. Thanks for watching.